Now that we have completed the wiring for the ultrasound sensor, let's write code and check out how it works. Here's what we will do in the code. 1. Find the distance from the sensor to the nearest object. 2. Print out the distance on the serial console. So let's start with the code. Open Arduino IDE. First let's start with the initial sections of including libraries and constant definitions. There are no libraries required. We need two constants, one for the echo pin and the other for the trigger pin. In the setup method, we will set the trigger pin as an output mode, and the echo pin as an input pin. Recall that the ultrasound sends out a pulse on its trigger pin and thus, the trigger pin has to be an output pin. The ultrasound receives the echo on its echo pin, and thus, the echo pin has to be an input pin. Now let's move on to the loop method. In the first few lines of the code, we do the following: we send out a 5 microsecond high pulse on the trigger pin. We then use the pulse-in method of Arduino library to check how long it takes to get back the pulse signal. Arduino's pulse-in method takes two parameters, one being the pin number, and the second being the type of value. In our case, when we say pulse in echo pin, high, it means, start counting the time in microseconds and wait for the echo pin to become high. As soon as the pulse become high, stop counting the time and return the total counted time, in microseconds. Thus, we get the total time, in microseconds, for the sound pulse to travel from the sensor and back. Using this time, we can calculate the total distance. Speed of sound equals 348.83 meters per second. Distance equals speed multiplied by time. We have got the time in microseconds. 1 microsecond equals 10 to the power of 6. Thus we get the distance as 0.000348 multiplied by t, meters. Converting this to centimeters, we get 0.0348 multiplied by t, centimeters. This distance is the total round-trip distance. So the distance between the sensor and the object is half of the above distance. That's it with the code. Let's compile, upload and check it out. Make sure ESP is connected to computer. Click on Verify and then Upload. Open Serial Console. The serial console shows a message giving out the distance from the sensor to the object. Keep an object at some distance from the sensor. Verify that the serial console shows the distance from the object to the sensor. Keep experimenting by moving the object to different distances. Verify that the serial console shows the right distance. Hooray! We have completed building this kit. Let's move on.